Am I audible? Am I audible?
Yes, sir.
Okay, thank you. So I think last lecture I think we have started the basic laws of thermodynamics. Am I correct? And we have discussed about the standard heat of the reaction. That is standard enthalpy. Standard heat means enthalpy of the reaction. And in that view, we have discussed about the enthalpy of formation. So I want that somebody should give me answer that somebody should give me answer that what is mean by formation reaction. Anybody of you? Anybody of you? Somebody can give. Nobody is ready with the answer. Anybody? So we have formation reaction means that kind of reaction in which reactants are reacting and they are forming only one single compound product. Means various reactants may react, but they should form only one single compound. So that kind of reactions we are calling it as a formation reaction.
डबल आवाज येतोय सर.
Double आवाज येतोय का?
Yes, sir.
Okay. Now it is okay.
Yes, sir.
So formation reaction, anybody can tell now? So formation reactions are the reactions in which only one single compound is formed by its different constituents, means by different reactants. A single compound. For example, we have taken example. that one half N2, let us consider that one half N2 gas plus 3/2 H2 gives NH3. So this reaction is called as formation reaction. Means here one half N2 gas and 3/2 H2 gas, they are reacting and they are forming only one single mole of a compound product. So that kind of reactions are called as their formation reactions. And the enthalpy associated with the formation reaction is called as standard enthalpy of formation. So this reaction occurs at 25 degrees Celsius. So 25 degrees Celsius means here 290, if we convert in Kelvin, it is 298.15 Kelvin. And conditions are standard. Standard condition means what? The in a gas, if NH3 is reacting in the form of gas, it should be purely ideal gas. It should not, NH3 should not contain its solid form or its liquid form. So when we say anything, any constitute, any reactant is reacting in the form of liquid, then pure liquid should be of that reactant should be uh, react or take place in that reaction. So there should not be liquid. If you consider liquid, it should not contain any kind of solid case or any case of vapor case or gaseous case. That kind of standardness, if you are maintaining, then that is called as standard enthalpy of the formation reaction. And if we know the standard enthalpy of the formation of different constitute elements, maybe for NH3, maybe for O2, NO, H2O, then we can calculate the standard enthalpy or standard heat of the chemical reaction. And for that, here for this reaction, if you want to calculate the standard heat, enthalpy means what? Heat. Remember that enthalpy is nothing but what? Heat content in the constituent. Enthalpy and heat content, both words are same. Okay. So enthalpy means it is equal to, you can write enthalpy means what? Heat content in the substance. Heat content in the substance. So if we know the formation enthalpies, these are the enthalpies of formation for NH3, NO, H2O. If we know the formation enthalpies, then we can calculate the standard enthalpy of the entire reaction, because enthalpy is a property and it is only depends on initial and final states of the system. So therefore we can do the mathematical operation as usual on the enthalpy operations. Okay. So 4Na3 plus 5O2 gas gives 4NO plus 6H2O gas. So for this reaction, so when we have to solve reaction, I request everybody to write this problem. Then next slide we'll go for the solution. Is it okay? Somebody can give response in the form of chat also, so that I can understand. If it is you are writing and you tell me writing is over, numerical write-up is over, so that we can go to the next slide, so that I will give the solution. Is it write-up is over? Somebody can reply. Somebody can reply. Asmita Sarvade, is the right step is over?
Yes, sir.
Okay, so you have to reply. So, okay. Abhishek Kamale is there. SA 47. Abhishek. Abhishek. Okay. Then to start this solution, what the formation reaction I will use? Okay, so the enthalpy of the reaction, let us consider it by delta H. We are denoting by the delta H. Very simple solution. Delta H, this indicate that everything is in the standard form with suffix O. Delta H for this reaction, okay, or at 298, if it is temperature is there T. This is what standard enthalpy of the reaction. So delta H is standard enthalpy because it is suffix O indicate that every conditions are standard and temperature is standard, or we can write in bracket 298.15 Kelvin is equal to, what we have to write, is equal to enthalpy associated, write down with me, enthalpy associated with product if formation enthalpies are given. Enthalpy associated with product minus enthalpy is visible, na? Enthalpy visible, na? Visible?
Yes, sir.
Yes, sir.
Okay, thank you. Enthalpy associated with reactants. So this is our formula we have to use. Okay. So in, if you want to give the symbolic representation, it will be what? Delta H standard for product, you can write T also, minus delta H standard for, okay, and now is equal to, what are the product now? Here we have to go for product. So here 4 into formation enthalpy of NO. So 4 into what? Formation enthalpy of NO. So we will go for square bracketing. 4 into NO is the product. 4 into product enthalpy of NO gases. How much it is given? 90.43. Okay. So into 90, very simple. So it is only subtraction. 90.40 plus, what is H2O? 6 into minus 242 plus 6 into, only sign we have to take 242. Okay, minus in bracket standard enthalpy of reactant. Which are the reactant? NH3 and here O2. Okay, 4 into NH3 minus 45, 72. 4 into minus 45.72 plus here, what is that? 5 into O2. 5 into O2. Now I want answer from your side. What is formation enthalpy of O2? If you were remembering on that day, I have told you these are natural compounds H2, N2, O2, and their formation enthalpies we have to consider as a
Zero.
0. Correct. Very good. So 0. This is the only operation is required in this case. It is 0. Okay. Then we have to do it operation and we have to find out the solution. Anybody can do it. I request everybody to solve this. Only science we have to take into consideration. This become minus will become plus afterwards. This minus and this plus. So I want answer from your side. Somebody can tell me.
Minus 907.4.
Minus 907. Correct, na?
Yes, sir. 0.4.
0.4 kilojoule. Only the answer we got kilojoule. So this is for this. This numerical is asking for 5 to 6 marks. Only this thing we have to go for. So only thing remembering is that when formation enthalpies are given and they asked if they will ask to calculate the formation enthalpy of entire reaction, then we have to use the formula delta A standard is equal to enthalpy associated with product minus enthalpy associated with reactant. So delta A standard T for product minus delta A standard for reactant. This indicates that the reaction elements are reactants are in their standard state, products are in their standard states. Okay, standard state means they should be here state here they should be solid. If reacting, it should be purely solid. Okay, it should not contain any of its liquid and gaseous form. Then liquid means it's purely liquid, not gaseous and solid form. If it is gas, it is purely ideal gas. It should not contain any solid or liquid impurities of its own. So, okay, so that will be the standard state, and pressure will be 1 atmosphere, 1 bar, and temperature will be 25 degrees Celsius or 298.15 Kelvin, and formation enthalpies are given of the different reactants. So everybody agree, understand this numerical? Very simple.
Hello sir.
And yeah.
Sir, unit kilojoule ka kilojoule per mole.
Already we have multiplied by mole, therefore it should be mole will be get cancelled now. If 4 is there, kilojoule per mole, but we are 4 moles we are considering. So here mole into kilojoule per mole, that mole will get cancelled. Therefore, final answer we are getting in terms of kilojoule per mole per. But these are the 4 moles. Are you getting?
Yes sir. Yes sir.
So this mole and this mole will get cancelled. So final answer will be in kilojoule. Everybody understood this? Shall I give practice numerical? 5 minutes you can now. This is the, and remember that the standard, write down in your notebook, standard enthalpies of formation for CO for H2, N2, O2 are to be considered as 0 formation enthalpies. Already they are formed in nature and therefore no energy is required to produce them. Everybody understand? Please reply so that I can get some confidence.
Yes sir.
Okay. Now this is a practice numerical. I will give 5 minutes and you give me answer. Calculate the standard enthalpy change at 298.15 Kelvin for the reaction C5H12 gas plus 8O2 gas gives 5 CO2 gas plus 6 H2O gas, and standard heat of formation is whatever constituents are there, CO2, H2O. And remember that H2O, the standard enthalpy of reaction will be always 242. CO2 it will be 393. It is standard. C5H12 it will be every numerical. If the numerical reaction may change, but these constitute elements formation enthalpy is always same. It is standard 146.5. O2 will be 0. Obviously, I think I request everybody to solve and make. I will give free to here 5 minutes. Okay. Our 5 minutes are sufficient. Everything you write. And if somebody, I think, so I'll write here only solution. Delta is standard T. Two 98.15 Kelvin. Or if you know the temperature, we are going to 98.5 Kelvin is equal to, write down, you write down enthalpy associated with product minus enthalpy associated with reactant. So I'll write delta H standard or 298.15 for product minus is equal to, you can do the operations. Okay, so what will be the case? 5 into 93 6 into minus 242 minus reactant side C5 1 into only one coefficient is only one mole of 146.5 plus 82 and is equal to, you do the operation. Somebody can
minus 3270.5.
minus 3 7 5 kilo. Are we getting? Such kind of simple examples are there. Only which we should know that the formula, that is if formation enthalpies are given to us, then here the sheet of the reaction will be enthalpy associated with product minus enthalpy associated with reactant, and then afterwards constitute formation enthalpy they are given, they are standard, and they are giving 5 into this if you, this numerical product are CO2 and H2O, moles of CO2 are 5, so 5 into formation enthalpy of CO. So this will be very simple numerical. Everybody understanding? Chat you can right? Yes, yes, sir. So that I can get little bit confidence that I am getting that you are concentrating. Yes, Pawan Shinde direct message. What is that? Yes, sir. Pawan Shinde. Good. Like Pawan, everybody have to share. Pawan, our friends are not joining. Whether they are attending, you can chat also. Other like Pawan, you can give message directly message. Okay, I request everybody to chat. Yes, sir, understood. Okay, very good. Okay, now good. I think Pradeep Dumar, yes, sir. Okay, thank you, Pradeep. Thank you, Asmita. Thank you, Pawan. Pradeep Dumar, yes, sir. Okay. Prerna Wankhede, I think, yes, sir. Okay, very good. Okay, now okay. Next is standard enthalpy or heat of combustion. Standard enthalpy or heat of combustion. So it is denoted by delta H standard CT. CT means what? Combustion reaction, and formation reaction is what? Delta H FT or T. Okay, let us consider this as a CT means what? C for combustion. Now we are going for another type of reaction, formation reaction. Now it is over. Now we are going for what? Combustion reaction. Okay, it is denoted standard enthalpy of combustion denoted by letter delta H standard T. Now we know that combustion is a oxidation reaction of the element. Combustion means what? A oxidation. If we combust anything, H2 plus, it is reaction of H2 with O2. Okay, it may form H2O. Okay, so combustion is any substance if it is reacting with oxygen, it is called as combustion reaction. Okay, oxygen means it is a oxidation reaction of the element. All combustion reactions are exothermic. Exothermic means what? Combustion reactions, all enthalpy, standard heat of combustion is always, anybody, exothermic means sign will be
Negative.
Negative.
Correct. So all combustion reactions, their standard enthalpies are coming as a negative because it is exothermic reaction. Always heat is evolved in the combustion reaction. Heat is formed in the combustion reaction. So definition is there that enthalpy change associated with the combustion reaction when reactants, here reactants, so it is reactants as well as product. It is a reactant. So spelling is wrong. React ANT. Reactants as well as products are in their respective standard state is called as enthalpy of combustion. So enthalpy change associated means delta H associated with the combustion reaction when the reactants as well as products are in their respective standard state is called as standard enthalpy of combustion. It is denoted by delta H standard T. This indicates that everything is what? In standard state. For determining standard enthalpy here, standard enthalpy of a given chemical reaction, the standard enthalpy of combustion of every element taking part in the reaction should be known. म्हणजे मगाशी आपल्याला त्यांनी फॉर्मेशन एन्थाल्पी दिलेल्या होत्या आणि त्याच्यावरून आपण मेन केमिकल रिएक्शन स्टँडर्ड हीट काढलं. तसंच जर एखाद्या रिएक्शन मधल्या एलिमेंटची कंबशन एन्थाल्पी जर दिली असेल, ओके, तरी सुद्धा आपल्याला त्या रिॲक्शनची काय काढता येते आपल्याला, स्टँडर्ड हीट ऑफ रिॲक्शन काढता येते. So I request everybody to write down at least this definition. Enthalpy change associated with the combustion reaction when reactants as well as products are in their respective standard state is called as standard enthalpy of combustion, and it is denoted by letter delta H standard CT. And you give me chart in your chart that write up is over, that is write up is over, so that I can proceed. 2 minutes are sufficient, I think. हाँ सर. Abhishek ji, Abhishek Kamble is over. Is it over? Asmita Sarvade, it is over.
Yes, sir.
Pawan Shinde, is it over?
Yes, sir. Over.
Okay. Now here only change is that they are giving the reaction. So here determine the standard enthalpy change at 298 Kelvin. So C3H8. So it is, I think it is, the reaction is like this. I will C3H8. It is what? C3H8 gas. C3H8 gas gives C2H4 gas plus CH4 gas, and here they have given standard enthalpies of combustion, not formation enthalpies. So the standard enthalpy of combustion for C3H8 gas is minus 221.54 kilojoule per mole. C2H4 gas is equal to minus 411.98 kilojoule per mole. CH4 gas is equal to minus 890.94 kilojoule per mole. And here remember that every substance there is a standard enthalpy of combustion. It may be wood, H2, it may be N2, like formation compounds. It is not the case with the combustion reactions. So every combustion, if any substance if you combust, it is giving some amount of energy. So therefore there is no concept of zero combustion enthalpy for anything. So if combustion enthalpies are given to us and they asked to calculate the standard enthalpy of entire reaction, then only change we have to go for is that delta HCF, that for entire reaction is here is equal to CT, okay, not a CT or 298 here 298.15 Kelvin is equal to combustion enthalpy associated with reactant minus combustion enthalpy associated with product. Only that formula we have to use. And there, if formation enthalpies are given, then enthalpy associated with product minus enthalpy associated with reactant. And if combustion enthalpies are given of element, then what we have to use formula? Combustion enthalpy associated with reactant minus combustion enthalpy associated with product. Only thing is that their product minus reactant. Here, when combustion enthalpies are there, reactant minus product. Everybody understand? Please mention in chat box. Yes, sir. Asmita Sarvade, Pawan Shinde, Prerna, Wankhede. Okay, good. Others, please reply. Everybody getting? So write down. So this numerically you write down. At the same time, you write down this also. Combustion enthalpy. When combustion enthalpies are given, what formula we have to use? Standard enthalpy of combustion of that reaction is equal to here combustion enthalpy associated with reactant minus combustion enthalpy associated with product. Write down, and if it write up is over, please mention in chat box this screen write up. Is it over? Sarvade, Asmita, Pawan Shinde. Okay. Over. Okay. Pawan Shinde over. Then next is you do the operations now. Reactant is only C3H2 gas. So minus 2 to 1.54 is only one constituent. Minus in that another reaction, C2H4 only one constituent. So here answer is what? Minus 2 to 1.54 is of C3H8 minus in bracket minus 411.98 minus 890 194, and answer is what? Here minus 918.62. Understood? Got the answer correctly? You have, the only thing is there that we have to remember the formula for that. Is it over? Understand combustion reaction? What do you mean by combustion reaction? And how to calculate the heat of the main reaction when enthalpies of combustion are given to us. Okay. So Arjun Ingoli is saying that yes, sir, understood. Others, please reply. Understood, sir. Yes, sir. Understand. Okay. Others, please reply. Only 3-4 students are only replying. So I am getting that. Abhishek Zaru. Yes, sir. Good, Abhishek. Now, one practice numerical. Okay, I am getting. Okay, Pradeep Dumar. Yes, sir. Good, Pradeep. Very good. Dumar. Yes, sir. Another message. Ganesh Gaudi. Good, Ganesh. Yes, sir. Good, good. Like that, everybody should reply so that I can get little bit confidence that you are understanding. Okay. Calculate standard enthalpy of formation of normal butane at 298.15 Kelvin from the knowledge of standard enthalpies of combustion. Delta H combustion reaction, delta H combustion, standard heat of combustion for carbon solid is minus 393.78. H2 gas is minus 286.03. C4H10 gas is equal to minus 2880.44 kilojoule per mole. Let down the reaction. So what we have to form? We have to form normal butane. What is formation reaction of normal butane? And but we have to use the standard enthalpies of combustion of the different elements taking part in the reaction. They are not given the reaction, but they asked to calculate what? Standard enthalpy of formation of normal butane. So normal butane means what? Butane means carbon atom will be anybody? Methane, ethane, propane, butane. Methane means carbon atom 1. Okay. Ethane means carbon atom 2. Methane, ethane, propane means carbon atom 3. And butane means anybody?
Carbon atom 4.
Carbon atom 4.
4. And what is formula for that hydrocarbons? Here it is CN. Remember that this formula CnH2n plus 2. These are the hydrocarbons formula, standard formula for the hydrocarbons. So if you take any example CnH2n plus 2, it is I think 12 standard you all learned this. Am I right now? Pawan?
Yes, sir.
Okay. So CnH2n plus 2. So if it is methane, if you take, then Cn 1C1 means and H2n plus 2n plus 2 plus 2 4 CH4. If it is ethane, C2 H2 plus 2 into 2 4 4 plus 2 6 C2 H6 ethane, and propane C3 H8 and C4H10 will be C4H10 will be normal butane. We have to form a chain. We have to write the formation reaction of normal butane, but to calculate the standard enthalpy of that main formation reaction of normal butane, you have to use the combustion enthalpies of different constituents. So what will be the reaction? So we have to form a normal butane. What is formation reaction of normal butane? Only 1 mole of normal butane gas we have to form. So it will be C4H10. Product will be what? C4H10 gas only, and only 1 mole, therefore there should not be another mole. So what will be for that? What is reactant required? H2 is required, constitute, and here carbon. So what will be 4 carbon solid if it is reacting, okay, plus here H2 H4 means H2, how many H2 will be required? 5. Correct, 5 H2 gas this is the formation reaction of normal butane. This is reaction. Now they have not given the reaction, but this is our reaction. 4 carbon solid plus 5H2 gas gives C4H10 gas. And for this reaction, we have to use the standard enthalpies of combustion of carbon H2 and C4H10. And for that, what we have to use? Delta is standard combustion reaction will be what? Enthalpy associated with reactant minus enthalpy associated with product. And if it is formation enthalpies are given, then enthalpy associated with product minus enthalpy associated with reactant. Now you solve this. I will give 3 to 4 minutes for you. The here it is that the formation reaction of normal butane is 4 carbon solid plus 5H2 gas gives C4H10 gas. Delta Ht it will be what? Enthalpy associated with reactant minus enthalpy associated with product. Okay. So only you make the square bracket. It will be good. Minus 2. Just check Asmita Sarvade and your answer. Writing minus 124.83. Just check. 4 into minus 393.78 plus 5 into minus 286.03. This is, yeah, Abhishek Jadhav got minus 124.83. Asmita, you check your answers, recalculate it. Adarsh Narayankar, very good, is minus 124.83. Prerna also getting, so you check. Asmita Sarvadi, you check your answer. Yeah, I think she is now on the right track. Okay, so this way, these are the numericals they may ask on the combustion, but maximally they have asked a numerical up till now on formation reaction. Okay, so just for I will give assignment. I will show you assignment. Is it visible assignment? You see the example. 7 March December 2014. Calculate standard heat of reaction for the reaction 2C2H6. So if I will give this as you further.
सर स्क्रीन दिसत नाहीये सर.
Okay, I will make it. I will make it. Is it visible now?
Yes, sir.
This is a additional numerical I have taken from assignment booklet. You can solve it. So calculate standard heat of reaction for the reaction 2C2H6 gas plus 7O2 gas gives 4CO2 gas plus 6H2O. Give me answer. This will be our last numerical. Okay, minus 2874.2. Okay. Okay, answer is what? So it is formation enthalpies are given. What will be answer here? Delta H standard T means is equal to delta H standard T for product minus, because formation enthalpies are given, delta H standard T for reactants. Okay, it is equal to what? Reactants are 4 into CO2 means what? Minus 390. Okay. Plus 6 into minus 242. The time is minus reactant will be 2 into C2H6 means minus 20 plus I will write 7 into 0. Imagine you are getting different answers. Minus 2874, I think is correct. I think for one. Just check. Just check. Minus oxygen will be 0. 2 into minus 2874. Majority we are getting minus 2874.2 kilojoule. Everybody understood? Very simple. So such kind of numericals are asking for. Okay, Abhijit Gaudi is also getting same. Okay. Maximum students are getting minus 2874. Prerna 1. Okay, so let us consider this as a majority case is minus 2874.2, and answer is this is correct. Okay, so with this I think we'll stop today, because I think I have adjusted 1 hour only for 3:30 to 4:30. So I think chat mention chat clearly that whether understood or not, so that we'll go for second of harmonize from today or tomorrow onwards. And ask your friends to join. If they are not joining, they will not understand. And if you are having doubts, etc., you ask in between. Understood? Okay. Then yes, sir. Understood. Understood. Good. Very good. Very good. So we'll take with this note. I think we'll stop today. Thank you very much. Thank you. You can leave the class.